السلام عليكم متابعيني خوشويست. لدرسي أو رماندا we'll talk about electrical force. So what is electrical force? We've mentioned before that if we have positive or negative charges, they'll repel one another. But if it is positive negative, they'll attract one another. But have you wondered how strongly they attract or repel one another? So today we'll talk about that force, Basha. So now the first thing, we have a definition. We can say electric force, which is the force of attraction or repulsion between the charges. And this force depends on the magnitude of the charges, also the distance between the charges, and the medium where the charges are as well. Basha, who is the first person we can say that made an equation and then calculated the equation between these charges? It was a scientist. His name was Coulomb, Basha. So what did he do? Basha, Coulomb stated that the electrical force between two charges is directly proportional to the product of the two charges and inversely with the square of the distance between the two. Now, باوي بيم قوتي بيكم equation later. Basha قلت ما هي electric force كمان هي. That is basically, or we can say the concept that we're going to begin with. Basha, electrical force ما بس ما نريد بابا. Let's just write it down here. Electric force, Basha. If I have two, let's say positive, they repel one another. If it is negative, that also repel one another. True, but if it is positive, negative, Basha, then they will attract one another, right? So, but with what force do they attract one another? Of course, it is directly proportional to the product of the two charges and inversely with the square of the distance between the two. Kata agar bain what we have said beacon equation, Baba, this is what we get. When the one blend electric force, the kata electric force, Basha, the kata yan it is equal to Yan Coulomb said that the electric force that is directly proportional to the product of the two charges, Basha, and inversely proportional with the square of the distance between the two. Basha, get away we pick up, we can write this as one equation. We can say Coulomb's law, for electric force, the product of Q1 times Q2 divided by the square of the distance between the two. Well, it is constant, it is called Coulomb's constant. Basha, so this would be the equation for the electrical force between two charges, let's say. Basha? So normally we know that forces are measured in Newton, Basha, charges are measured in Coulomb, Basha. So this to Coulomb, you can say Coulomb squared, the distance is measured in meter, but because it is distance squared, so we can say meter squared. What about this Coulomb's constant, Baba? Agar بتيو constant abzani intaketia, amzare dekena subject, Basha. Make that the subject and see what is equal to. It is equal to force times distance squared divided by Q1 Q2, Basha. So later okati unit can indibita unity force in Newton, unity distance meter, but because it is squared, kata the beta meter squared, unity charges Coulomb times Coulomb, that would be Coulomb squared kata. We can say the unit of Coulomb's constant, the kata Newton times meter squared divided by the Coulomb squared, Basha, Newton meter squared divided by the per Coulomb squared, Basha. But taban au magnitude because it is a constant, Baba, it has a fixed value, Basha. Unit takiyan babun value ke dakata 8.99 times 10 to the power positive 9. Good morning, Newton meter squared over Coulomb squared, Basha. Kata, this is the magnitude of K here, this constant. This constant, obviously, we can say it is for the medium, Basha. All right, where the charges are, we could say. Basha, kawata, electrical force, Baba. It is the force of attraction or repulsion. Electric force, it is the force of attraction or repulsion between charges. Or force gutman depends on what? Depends on the product of the two charges, Basha, and also depends on the distance between the two charges and the medium where the charges are. That is Coulomb's law, Basha. And of course, based on this equation, we can say Coulomb stated that electrical force directly proportional to the product of the two charges and inversely with the square of the distance between the two. It is very important that you need to know. Based on this, we can see that electrical force is directly proportional to the two charges. Charge electric force charge 1, charge 2. But it is inversely with the square of the distance between the two. I need you to make a pause on this one. What exactly do we mean by this? As that, for example, let's say we have two electrical charges, Basha. Again, if the distance between the two is, let's say, increased or become double, Basha. Again, distance بينهم زاد كن. So, for example, previously they were this much apart. Okay. So whether positive, negative doesn't matter. If it is positive, negative now, they'll attract one another. Let's say this is the distance between the two. If we increase, there's a certain distance. If we increase the distance between the two, so distance كيف كان 2r باشا. ليرة تنها r ليرة distance كيف كان 2r يعني double بونيات. Distance كليرة هات صندق بليرة 2 times that كاتا distance double بو. باشا قد distance double بيتين force بينان تيليده. باشا. You can see that the two charges are separated furthermore. كاتا force كزيادة كان كم دكا. But how much exactly will it reduce باشا؟ أو كاتي بين equation كي بنوسو بابا. قلت مان ليرة distance كهات صندق زيادة كديان كميكل لنا equation كيان بابل لنا relation دابنو equation relation وبزانة تيلي ديتو قلت مان ليرة distance كبو دو جار باشا كواتا power كش لبير مكا 1 over 2 squared باشا كواتا ليرة تيلي دي بيتا 1 over 2 squared بيتا سن بيتا 4 كواتا force كتيلي هات the force just became 1/4 of the first time كواتا force كات صار زار كميكل compared to what we had before. Basha, what happens if we, let's say, or another case here, if the two charges are far from one another, what happens if we bring them closer? Let's say the force between two negative charges, they separate, they're moving, like they push each other away because they repel each other. But what happened, let's say here's R, what happened if I bring them closer now, Basha? These are the two charges or same charges. بس استعليش هنزيق دكينو باشا distance كمان كده بابلن distance كده بيت النيوي بيشتري which means half of the previous one as that force بينان تيلي do you think it will increase or decrease? Of course it is going to increase كده يقدر نزيق بنا سكاتا دو charge كده يقدر نزيق بن force كا it becomes stronger أجر دو charge كده يقدر يدور كونه the force becomes weaker as that since the two charges brought closer كاتا force بينان زاد دكا but how much will it increase قد ما relation كده بنوسو relation كا force that is inversely proportional with the بابلن square of the distance يعني بابلن distance squared ونيا هستعيل جاتي آرك بيتسن it is 1 over 2 كاتا براكتة شفكو ده تواني بلي 1 over 2 ونيا بزاو square كاتا 1 over 2 square ده بيتسن تواني بلين force كا it is equal and becomes باشا or you could write this one doesn't matter here that'll be 1 over 2 squared that'll be 1 over 4 ونيا أجاو فرد تيتا سريع ده بيتا 4 times أنا شاكر بحاسبي ليش دي بابا 1 over 4 كاتا والله ما كده بيتا 10 والله ما كده بيتا 4 times استا فرصة كزيادة كديان كم يكد استا فرصة كزيادة كد 10 زار جادي كد 4 times ونيا أجا ذكري ليرة هرش مارك بيتن مثلا ليرة ذكري 1 over 3 بيتن 1 over 5 بيت doesn't matter ونيا هرش مارك چند دايش مارك يبين الإيكويشن كي دابنو دتواني بيبينيو باشا أو أجر قوتي distance كا غورا وندا by this much ونيا but what if we do the reverse أو let's say the force is doubled ونيا in order for the force to be doubled distance كتسيلي دي باب عين برسار نتوانا بلبزور اسفاد لو فكرانا ده كان لو grade 12 إن شاء الله ماشي برسار شديكة هم بيني بلين أجر force بيني do charge for example the force between two charges is doubled باشا if the force between the two charges is doubled by what factor the distance between the two should change ونيا لو حالتي بابا because the question is about force and distance do about relation كي بنوسو قلت ما relation بيني force and distance تيا 1 over r squared ونيا استاكا شيمان what is given or what do we know force كدريا so once you write the equation baba whatever that is known just put the number there and you can find whatever that is unknown here Masha later the question says the force is doubled we can say 2 it is directly proportional to the r squared but come on there can you swap this to here using cross multiplication or whatever yes r squared it is directly proportional to 1 over 2 Basha but we want the r not the r squared you can take the radical square root for both sides أو دو cancel the بنوع كاتا أركتي لده أركت بيته 1 over باشا radically 1 is still 1 أو يديكش radically 2 you can write it as 1 over 2 باشا كاتا in order for the force to become double ده بي أركب بيته 10 أركب بيته 1 over the radical of 2 أو زد تواني بحاسبي calculator you can calculate this number as well which is going to be something when you كاتا the distance must change by this factor أقال لي كاتا وإلا سرت ضرورة بزاني بابا أو relation ماشي force is inversely proportional with the square of the distance أو زي distance كتشنج بو just replace yan bubbling, plug in the number here. Agar forsa ke dagoti distance ke babino, plug in the number 0.2 bugorowa. Now the r is the subject, square root and then you can find the value for the r تكبسارشي بونو عمان here. زور باشا تقريبا نتوانم بلن electrical force دي كشمانية which is related to this. طبعا the only reason that we're studying this because we have a question that is kind of like comparing the electrical force and gravitational force. Which one of these two do you think it is stronger? So now we know that there is, if I have two masses, let's say this is one of them and this is two. We know that these two masses attract one another because of a force that is called gravitational force. So what is gravitational force? It is almost like similar in construction to electrical force. We'll say gravitational force, Basha. Gravitational force, it is a force of attraction, Basha, that is directly proportional to the product of the two masses. Go to the product of the two charges. Directly proportional to the product of the two masses and inversely proportional with the square of the distance. What do we call this one? We call this one gravitational force, Basha. And then there is this G, which is universal gravitational constant and also has a fixed value as well. We can say 6.67, I believe, Basha, times 10 to the power negative 11. Bubbling time is mass 1, mass 2 divided by the square of the distance between the two. Because now when we talk about charges here, if we have two charges, let's say Q1 and Q2, these two charges obviously have a certain mass. So these two charges, or there are, of course, gravitational force between the two and electrical force between the two as well. But which one of them will be stronger? Obviously, gravitational force is way weaker compared to electrical force. How do we know this, Baba? If you rub the balloon with the hair, it can make the hair stand on its end. Isn't gravity pulling it down? Yes. So, but why does it stand on its end? Okay, electrical force, it is stronger. If you rub a balloon with another balloon with their hair, it can stick to a wall, for example. But why does it stick to the wall here? All right, this question is also worth, like explaining a little. But once it is, for example, charged, it can stick to a wall. So this is a balloon here. All right, and this is a wall. Let's say the reason why this to stick because clearly there is a electrical force between the two. This electrical force here, we can say that it is way stronger, Basha, than gravitational force. This is the reason why it can stick. Again, gravity would pull it down. It doesn't let it stick to the wall because it should have, or must have fall down instantly. But we know that that's not the case. As long as the balloon sticks to the wall, that means gravitational or electrical force that is stronger than gravitational force. That's why it can stick to the wall. If I summarize this one, Baba, we have two forces at this point. We have electrical force and gravitational force. Electrical force that is directly proportional to the product of the two charges and inversely with the square of the distance. For gravitational force, it is directly proportional to the two masses, to the product of the two masses, and inversely with the square of the distance. They have something in common. Electrical force, let me rewrite it. Electrical force K coulombs constant, Q1, Q2, right, divided by the square of the distance between the two. What about for gravitational force? Fg stands for gravitational force, that is G capital M1, M2 divided by the square of the distance between the two. Even though these are about charges here, these are about masses here, but if you look, for example, at this point here, these are both, of course, we can see that it is inversely proportional with both of them are inversely proportional with the square of the distance between the two. لو خالي بيتن باشا وهركات شيش برساب دباري يعني باولن سواري بهري كتشانكرا, of course, you could just write them down, plug in the numbers, do the calculation. And then that's it. I believe there's nothing more than that. So now let's get back to the question and perhaps maybe highlight a few things and then solve a few questions here. So the first thing that we have electric force, it is the force of attraction or repulsion. Positive, negative, they repel one, that is a repulsion. But if it is positive, negative, they'll attract one another. Basha, the force of attraction or repulsion between two charges or two charged object, and this is determined, of course, by what? by their charges, by the distance between the two, and the medium between them as well. قلت ما كولوم بلوتيا. It is einen dubara. It is about electric force. We can say it is the force between two charges that is directly proportional to the product of the two charges, Q1 and Q2, inversely proportional to the square of the distance between the two. There's one thing I need to tell you, Baba. When it comes to electrical force, once you, for example, write the charges here, we will always write their absolute value. Oh, we will never write positive or negative in the equation of electrical force. For example, we have an electron and a proton, right? We know that electrons are negative, protons are positive. So do we write the negative positive into the equation? We don't do that, Basha. So how do I know, for example, because electrical force is a vector quantity, that has both magnitude and direction. So how do I know the directions? Well, it is obvious. If the two charges are positive, they will repel. If the two charges are positive, negative, then they'll attract one another. You can tell even without plugging the negative positive sign into the equation. Basha, you can always write the absolute value of the two charges. You don't write negative positive in the equation for electrical force. And there's also one more thing, Baba. So Gutman, if these two are the charges here, let's say Q1 and Q2, doesn't matter how big or small they are, Gutman, these are both attract or repel one another. So the force that they attract or repel one another, it is always going to be equal in magnitude, but opposite in direction, Basha. Always, Basha. So no matter which one is smaller or bigger, they will always have the same force, Basha, or these two will always apply the same force on each other. Basha, Gutman, these are what you need to know, Gutman Efaka. This the force, electrical force measured in Newton, Q1, Q2, these are the charges measured in Coulomb. Gutman, R is the distance measured in meter, Agad and this one, K Coulomb's constant is approximately 8.99 times 10 to the power positive 9, that is Newton meter squared per Coulomb square. Agad shullo khala nabi baba bataybat datwani blin khali dua mukhali pensum. Basha Gutman, the force between two charges is directly proportional to the product of bas market of the product of the two charges and the magnitude of the two charges. Kadain magnitude mabasmano baba. You just write the number without positive or negative. Inverse square law, taban, this is something very important. Gutman, the force between the two charges, it is inversely proportional to the square of the distance. Once we have something like that, we call it the inverse square law. And we have even this, like we have this one even in grade 12. So it is very important to understand this one now. Kadan inverse square law mabaslansia Gutman forsaka, it is inversely proportional. It's called inverse, Basha. Kata, it is the directly proportional to the Yan square, Yan to the inverse of the square of the distance. Gutman lera as a forsaka and distance, whichever that is unknown, you just plug in the numbers and work it out, do the math, and that'll be it. Now, electric force is a vector force, like charges repel while unlike charges or opposite charges attract one another. Later, Baba, let's make that an equation again. You can write it down. Doubling the distance. If we double the distance, what happened to the force, Kaka? The force becomes 1/4. Now, this will be the first part because the force is directly proportional to the inverse of the square of the distance, right? So now, because it says doubling the distance, when you're doubling, making the distance 2, but 1/2 squared, that'll be 1/4. It becomes 1/4, Basha, 1/4. What about halving the distance? That'll be the second part. While halving the distance, that means making it half, 1/2. Right? The distance, the force increases, that increases the force 4 times. How is that? So force again, it is directly proportional to the inverse, inversely proportional with the square of the distance, Basha. So now later distance can be half, 1/2, but because it is half, the beta 1/4, Basha. 1/4. We can say that the force becomes 4 times larger here. Calculator, use this number, of course, you'll get 4 times kata. The force increases 4 times if the distance between the two charges become half. Newton's law of gravitation. That's a gravitation law. It is the force of attraction. طبعا gravitational force there is one huge difference between electrical force and gravitational force. In electrical force, we could have positive, negative charges. They repel one another, right? But if it is positive or negative, they attract. For electrical charges, they can attract or repel. But for gravitational force, it never repel. The only thing that it does, it is attracting. For example, you drop a pen, right? It never floats upward, then it is always attracted to the other mass. For example, now this pen will be attracted and bubbling. There is an attraction force between the pen and the earth, you could say that. Basha? Gravitational force, it is only attractive force. It can only attract one another. It never repel. But with my similarity, for gravitational force and electric force, they're both inversely proportional with the square of the distance. Later, the electric force as a force here, is the force of attraction, only attraction between two masses is directly proportional to the product the result of a multiplication of the two masses, and inversely proportional to the square of the distance between them. As an equation, this is how we write that. But I got the equation. This G is a constant, obviously you'll be given, Basha, so don't worry about this value. In grade 12, we have the same thing, by the way. Then there you can memorize it yourself. Basha, F is a gravitational force, M1, M2, these are the masses, R is the distance, and G is the gravitational constant, which is approximately 6.674 times 10 to the power negative 11. Basha? I hope we said it right the other time. Basha, Kata 6.67 times negative 11. Here, which is related to both equations here. Basha. And of course, all right, let's just go through this one here. The question says, the electron and proton. Basha, what do we have? The electron and proton of hydrogen atom. So how many or what are the charges that we have? One of the charges that we have, it is an electron. The second charge that we have, it is a proton here. You agree with me, Wrya? Okay, so now you can write it down for yourself here. Mandela, the electron, you can make this one Q1, and proton, you can make this one Q2 here, of hydrogen atom are separated on an average, Basha, by a distance of about this much. So this is the distance here, or you can call that R. The first part of the question says find the magnitudes. Find the magnitudes of the electric force, and then the magnitude of a gravitational force. There's one thing here I need to tell. Actually, let me just write it down. So after you write the information given here, we'll say electrical force, dakata K, Coulomb's law, Basha, Q1, Q2, divide by what? Divide by the square of the distance between the two. But later charge can see baba charge can protonu electron. The charge of an electron here, or the charge of a proton here, you can write them E for electron, P for proton, doesn't matter. Their magnitude is both the same, which is 1.6 times 10 to the power negative 19 coulomb, Basha. And for proton, it's exactly the same thing. These are their magnitude. But man, I get basi the value for that electron beta negative, proton beta positive. But when we say magnitude and their value, both of them is exactly the same thing. Now all you have to do, just plug in the numbers, Basha. Got the electric force again, the kata K Coulomb's constant, good man. This will be given, that is 8.85 Basha times 10 to the power positive 9 Basha, and then multiplied by charge 1 and charge 2. Because the two charges are the same now, you could just write 1 and square them. I'll just write them both. 1.6 times 10 to the power negative 19 times another time 1.6 times 10 to the power negative 19. Like I said, you could have wrote one of them and square them, because if these two are both the same, you could have just said charge square. But that is only applicable if the two charges have the same magnitude. This it is 5.3 times 10 to the power negative 11, right? So we're done. No, we're not done. Open a bracket, or let's say use a bracket and square that, because it is square. Now, if you, of course, do the math, this is too big here, we'll just write it here. If you do the math, of course, you'll get an electric force, it is equal to 8.2 times 10 to the power negative 8, since it is a force that is measured in Newton. So that you can find it easily later, once needed. The second part of the question says, so we found the electrical force, and now find the gravitational force that each particle exert on one another. So how do I find the gravitational force here? Good man, equation gravitational force, okay? It is almost like very similar to electrical force. For gravitation here, we'll say Fg decat, that's it. Good man, G capital, M1, M2 divided by the square of the distance between the two. But later, يكتشان proton, يكتشان electron, the mass of proton and electron are different, so the masses will be given to you. Kata mass electroni man senda. Basha mass electroni it is, and babylon proton it is 1.673 times 10 to the power negative 11, but the mass of an electron it is about 9.1 times 10 to the power negative 31. So all you have to do just use these numbers. When you're starting with G Gutman, it is 6.67. You don't have to write the whole digits, Basha, times 10 to the power negative 11 times Basha Gutman mass yakam. We could say mass of an electron, doesn't matter. 9.1. Even if you don't write the whole thing, that is fine. Times 10 to the power negative 31, that is kilogram. Massi protoni decata 1.67 times 10 to the power negative 27 kilogram, divided by the distance, square of the distance between the two. Of course, the distance is still the same thing, Basha. Kata 5.3 times 10 to the power, Gutman, negative 11 meter, Basha. But Gutman, this is also squared. So once you do the number or do the math, all right, so by the way, every time, first of all, you do the whole thing, the whole numbers that are the numerator, open a bracket, write this, close bracket, then square that. This is how you get it right. FG kadakata 3.6 times 10 to the power negative 47 Newton, by the way. See the difference between the two here? Electric force is 8.2 times 10 to the power negative 8. Here this is 3.6 Basha times 10 to the power negative 47 Newton here. So we know that when we have negative powers, the bigger the power, that means the smaller the number. But at this point, you can see that electrical force, in comparison, it is much stronger than gravitational force. So we can say electrical force, it is much greater than gravitational force, let's say between an electron and a proton, Basha. So percentage Joanna, of course, worth knowing that one. percentage دي كمان هي عندك percentage دي كلها حل كل practice كان practice 6a. The first question that we have says what? A balloon is rubbed against a denim. What is a denim? You could say a piece of cloth, a piece of jeans, you can say, Basha. So there is a balloon, that would be the first object, and there's the second object. But look, it says the balloon gains, Basha, so a balloon rubbed against a denim gains this much. So the balloon gains a charge of negative 8. How much is this, by the way? This is micro, and yeah, micro is 10 to the power negative 6. You do agree, right? All right. The question says, what is the electric force between the balloon and the denim when the two are separated by a distance of that much? So here's a distance, right? But there's one thing you need to know. And what is that thing? Here, it only gives you the charge of a balloon. What about the charge of a denim? If you have two objects, Basha, if one electron is removed from this object to this one here, so this one becomes, let's say, negative 1, yeah? Negative 1. What about the charge of the other one that the electron is removed from? This one becomes positive 1. When we have two objects here, one of them is a balloon, Basha. One of them is a balloon, Basha. And the other one is a denim. You could say a piece of cloth, Basha. All right, so if the charge of the balloon becomes what? Becomes negative 8 micro is negative 6, by the way, coulomb. So the charge on the denim is going to be exactly the same amount of charge, but opposite, which is going to be positive 8 times 10 to the power negative 6 coulomb, Basha. So these are the two charges on both of these two objects here. What's a Pasarika? So the question is asking, what is the electric force? You can write the information given here. Q1, of course, equal to that much. Q2, let's just write it down. All right, so get my later delete the negative 8 or 8.0 times micro, which is negative 6. Basha. This is coulomb. Q2, it is going to be the same thing but positive, Basha, times 10 to the power negative 6 coulomb. And then the distance between the two, it is 5 times 10 to the power negative 2 meter. And you can write the coulomb's constant, which is 8.0 8.5 times 10 to the power positive 9 باشا ينتكش تاني بينوس يعني ليك right مشكلة نه فهذا electric force in here the تاني بلين electric force تكاتت قلت مان K coulombs constant Q1 Q2 divide by the square of the distance between the two. Now all you have to do just do the math. قلت مان K دكات 8.85 times 10 to the power positive 9 don't forget times charge كم تنبو قال لي ببابا قلت مان positive negative values are not written in the equation so we don't write them we'll just write the magnitude here قلت مان دلن 8 times 10 to the power negative 6 times charge دوما نسمبو it is also 8 times 10 to the power negative 6 you could have just wrote 1 and squared that but we'll just write the whole thing basha and then divide by the square of the distance between the two which is 5 times 10 to the power negative 2 بس I got low square beaten now do the math of course you will get the answer the force supposed to or should equal to 230 newtons that is the electrical force between the two. All right, now let's move on to another question maybe. All right. Now this question is also very, it's a good question actually. What does it say? It says two identical conducting spheres are faced with their centers 0.3 meter apart. Can I call this one the distance between the two? Yes, one of them given a charge of this much, so you can call this one Q1. So let's just write it down. Q1 it is 12 times 10 to the power negative 9 coulomb. The other one is given a charge, so these two charges are not the same now. Negative 18 times 10 to the power negative 9 coulombs here. But man, the distance between the two, it is 0.30 meter. And of course, you can write the value for K as well, which is 8.85 times 10 to the power 9. Basha? The first part of the question says, find the electrical force exerted on one sphere by the other one. Good man, the two forces, oh, let's say these are the spheres here. Man, the two forces, all right, are equal in magnitude and opposite in direction. So whichever the force you find, it's the same as on the other one, Basha. So there's a distance that separates between the two spheres as well. So you can call this one sphere 1 and this is sphere 2. So once again, here at this point, we can say electrical force equal to K, you could write it here by the way, Q1, Q2 divide by the square of the distance between the two. So once again, electrical force, it is equal to K, it is 8.85 times 10 to the power positive 9 multiplied by charge 1 and charge 2. Man, positive and negative, so one of them was 12 times 10 to the power negative 9. OIDK was 18 times 10 to the power negative 9 divided by the square of the distance, which is 0.3 but squared. Once you do the math, of course, you'll get the electrical force, which is equal to 2.2 times 10 to the power negative 5 Newton. This is the electrical force between the two charges. Now that's a good one actually. Now the second part that we have, part B, all right, what is part B saying here? Part B says the charges are connected by a connecting wire now. So these are the two charges, all right? They're now connected with a conducting wire. So you can see that here, one of the charges has more, one of the spheres is holding more charge than the other one. One of them is 12 times negative 9 Babylon. OIDK 18 times 10 to the power negative 9. So clearly there's more charge on this one than the other one. So once you connect them, charges are going to flow or move from the one that has more charge to the one that is less charge. Just like the, what is it called? Yani maybe the pressure or diffusion here. Charges will flow from a region where there is more charges to a region where there is less charges. But the question says what? After connected, it says, after equilibrium has occurred, find the electric force between the two. So how do we know what happens or how would it be at equilibrium? So when we say after equilibrium has occurred, Yani, you'll have to add the charges, all right, and then divide by 2 just to find the average charge on each one of them. So in order to see, for example, how many charge will be on each one of them, you'll have to add the 2 charges and find the average charge on each one of them, Basha. So we can say average charge on each one of them. That'll be charge 1 plus, Basha. We can say plus charge 2, right, divide by 2. This is how you can find the average charge on each one of them. How do I know how many charges, for example, will be there? Gutman, do charge ke add dake baba, total ke de binyo divide to dake, atabzana har sphere san charge babar dake written basha. Kawatale the 12 times 10 to the power negative 9 basha plus 18 times 10 to the power and of course this is negative, don't forget, times 10 to the power negative 9. Now divide by 2 because some of them are positive and negative, right? So you have to be aware of that one as well. So clearly this one has more charge than the other one, so this would dominate. So once we do this one, of course, we can get the average charge on each sphere now, Basha. Average charge on each sphere. What is it going to be? It is going to be negative 3 times 10 to the power negative 9 coulomb, Basha. So this is how much charge is going to be on each sphere now, Basha. If that is the case, then what is the electric force now between the two, Basha? So once again, electric force between the two, that would be part B. All right, electric force between the two, we could say electric force between the two, it is equal to K, Q1, Q2 divided by the square of the distance between the two. And then, so once again, 8.85 times 10 to the power 9 times, is that what is the charge on each one of them? Gutman, we don't write the negative in the equation of electrical force. So 3 times 10 to the power negative 9 times another 3 times 10 to the power negative 9 divided by the square of the distance. Gutman, distance it is 0.3 meter. Square that one here. Now, of course, the electrical force is going to become what? Electrical force now, it is going to be, you can say electric forces now, it has to be 9 times 10 to the power negative 7 Newton. This is the electrical force after the two charges have reached equilibrium. This question is a good question because it is asking for the distance here. Well, two electrical or electrostatic point charges. So we have 2 point charges. Basha. So one of them, or you can call this one Q1, it is 60 micro. Got my micro negative 6. You could write it down. The second one, it is 50. That is Q2. Exert a repulsive force on each other. The force that is given here, that is 175 Newton. What is the distance between the two charges? Come on. What is the distance here? We can write Q1, which is 60 micro, is negative 6 coulomb. Q2, it is 50, right? This is obviously, these are both positive, but man, 50 micro, 50 times 10 to the power negative 6 coulomb. Man, distance, yeah, and force, the force between the two is 175. Clearly, these are both positive, so it is repulsive, yani. What is the distance? Okay, it is 8.85 times 10 to the power 9 here. What is the distance between the two? Alright, good man. Electrical force good man K, right? Let's just write this all together now. K, Q1, Q2 divided by the square of the distance between the two. So we're looking, or we don't have the distance, right? So can you just swap this to? Yes. So we can say the distance squared, K, Q1, Q2 divide by what? Divide by the force. Now all we have to do, just plug in the numbers now. 8.85 times 10 to the power positive positive 9 times charge U1 or charge U2, and these are 60 micro, negative 6 times 50 micro, negative 6, and then divide by the force, which is 100. What was the force? It is 175 Newton. Now, once you do this, of course, you get a certain answer here. But look, this is r squared. We don't want r squared, right? So what do you do next? Right? If I want to write it here above, right, we'll say take the square root for both sides, whatever the answer is, right? Take the square root for that too. right? Take the square root for both sides, then r, of course, you'll find out it is going to be 0.393. You can even round it up to 0.4 meter as well. So this is going to be the distance between the two. Basha? All right. These are, I believe these are not important here. Okay. That'll be the end for this session. Till then, keep practicing, and I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.